Welcome to Khetz Tutorials, and in this video I'll just be continuing on my discussion about analytical geometry, but in this video I want to specifically talk about the equation of a circle. So let's write that down. Equation of a circle. So I did touch up on this quite a bit in the previous video, which I just link in the top right. And I'll just continue or just add on to what I've already said. And just to recap on what I did say, the standard form, just as any function or anything in mathematics basically has a standard form, this would be a standard form to describe how your circle would look or the behavior, size, and shape of your circle. Anyway, so the A would be the x-coordinate of the center. So x-coordinate, just write it like that, of center. And the B, so this is the A, and that is your B over there. And note that you have a negative in the standard form, right? As I said in the previous video, if you ever have such a case, let's say you have something like this, then you would know from the standard form that the x-coordinate is actually -3, because if you put -3 over there, the effect of the minus sign in the standard form on that will become a positive. So if you ever have a positive, then you know that your coordinate should be negative anyway. So that is how you deal with such cases. And now the B is the y-coordinate of your center. So A, B describe the center of the circle. So let's say you have a circle, then at the center you basically have A, B. And you can just take them out from your formula. So if you have this as your formula, then that would mean that you basically have 0 as your center, or your circle is basically centered around the origin. So if you have the Cartesian plane like this, then you expect to have your circle with the center over there at 0, 0. Because if you substitute those values into A and B, then this is what you basically get. And now on the other side of the equation, you have R, which is the radius of your circle, right? So the radius would be a line which originates from the center to the circumference. So from the center to the circumference, and as I said in the previous video, it can be in any direction as long as it originates from the center to the circumference being any point on the outline of the circle, then it is a radius. Now when we talk about diameter, it is twice the size of the radius. And here's why. Now your diameter would now start on one side of the circumference, pass through the center, and go all the way to the other side of the circumference. So in that way, you can see that since we said that the radius is basically a line from the center to the circumference, you can see that a diameter makes 2 radii, basically pronounced them like that, I think, but this is how you write it or write it out. Radii, or however it's pronounced, doesn't really matter. As long as we know that a diameter is basically twice the radius. So that is a fact. You have to know that, because sometimes you might be told the length of a diameter, and you then have to find the length of the radius by dividing this by 2 basically, and you have your radius, which you can then substitute into the standard form. So you should always think about the equation of a circle in terms of its standard form, which is this over here. Now sometimes you might find that you aren't given the equation in the standard form, but you are asked to actually give it in the standard form. And before we get to that, now let's say you have a just want to make an illustration. Let's say you have a circle like this, and it has this, and you're asked to give the equation of this in the standard form, and perhaps you have another point on the circumference called B, and then C for center, or whatever the case may be. Let's say you have the coordinates of this thing. You can then find the length of CB, and that would be your radius, right? And then now, after finding your radius, you're just going to write your standard form formula out. It's always advisable to write out your formulas before you substitute anything, just so you trace back and check if you haven't made any mistakes. And now you're going to substitute the x value of your center into that. Then you're going to substitute the y value of your center, then find the length of CB and substitute it where you see R and square that. And that would be your equation in the standard form if you ever have such a case where you're given a circle and you can find the radius easily. So you can just look at this as just a mix and match of things, but the basic principles apply. As long as you know that the radius basically moves from the center to the circumference, you can always find a way. And the question setters, or whoever sets the questions, will basically just work around seeing if you know your formulas or if you know what's actually going on. So obviously some complexity will be added to this so that you actually find some other stuff, but this is the basic principle behind the equation of a circle. And now let's say you had a diameter, for example, and you also knew this point, this other point on the other side of the circumference, and it had some coordinates. Let's say you wanted to find the equation giving a diameter and you didn't know the coordinates of the center. Now you'd use the midpoint formula to find this point, to find the coordinates of your center, because the center is right in the middle of your diameter. And you'd find the length of the diameter, then divided by 2 to find your R, and then substitute it in there. So you can then substitute the coordinates from the midpoint formula into there, and then your R, which is the diameter divided by 2, into the R position, and square it again. So as you can see, the same things always pop up, just that you have to know what to look for and how to get it. Now, as I was saying previously, if you are given an equation which is not in standard form or in its standard form, let's say, for example, you have something like this, and you are, let me just fix this. Let's say you're asked to write this in the standard form. Now, how would you do it? So the answer to this is you have to complete the square, and you can go back to my algebra video, which I just link. I think I did talk about that a long time ago. And if not, or let's say, let's just do it actually. So how would you do this? So to complete the square, you just check which variable has some other powers of it, if I can put it like that. So as you can see, x squared is by itself, but the y squared has another power, or the y, there's another y present in here, right? So we can work with that. We know that we have to do something with the y because the x is already sorted. There's nothing else related to the x. So let's see how we can complete the square, because what we want to end up with is something like this, something there, squared, and y squared equals to r squared, right? So we want to transform this long equation, which is associated with y, to something which looks like this. That is what completing the square is about, and that is what we want to do right now. So let's do that. So here's how you basically complete the square. So you now check which variable has another value. So y squared has another y value, but x is basically sorted out. So here's what you basically do in general. So let's say, for example, you had x plus 1 equals to 0. Now, if you add and subtract the same value to this, then you basically keep the integrity, or basically keep whatever this was. So I've added 5 and I also subtracted 5. That means the effect of these two is 0, which means this is exactly the same as that. And this is the principle that is used in completing the square. But now, since in the quadratic form, we usually say that we have ax squared plus bx plus c. Now, using this, you basically take minus b over 2, then you basically square that. And in our case, we have we're dealing with y, which is this part. We have 6 minus 6 as the coefficient, or as b. So you're going to say minus 6 divided by 2. Then you're going to square that. And everything remains as it were. And you're basically going to have this. And on this side, you have this. So we've added this. We must also subtract it, right? So let's subtract it as well. So okay, so in here we have, let's see what we have. We have this thing, which will become positive. Then we have 6 divided by 2, which is 3, and 3 squared is 9. So now here we have 9. So let's write this: x squared plus y squared minus 6y plus 9 minus 55 minus, this is the same thing. And there should be minus over there. Now this is a plus, and then 6 divided by 2 once again is 3. 3 squared is 9. And now we can take these to the other side of the equal sign, and on the left side, this is what will remain, equals to 55 plus 9, which is 64. And this is basically familiar, or you can break this down into a square. But now, if you don't want to really trouble yourself with how you'd get there, as long as you are done with this manipulation, or as long as you're done with all of that, the process that got you here, then it's safe to say that, okay, x squared is dealt with. So you just copy it as it is. But now your y, you basically put that into a bracket and you square that. And in here, you basically subtract the other value. And the other value would be your minus b divided by 2. Now, in our case, minus b divided by 2 was minus 6 divided by 2. And if you do that, so let me write this properly. So it's minus b divided by 2. Then we also put that in the square thing, right? And you can prove that this is actually equal. I'll do that in a bit, but I just want to write the final answer. So we've now converted the original formula, which looked something like this, into the standard form which was asked for. So this is how you basically transform an equation which is not in the standard form to the standard form. Basically, that is what we've been doing by completing the square. And you basically say y minus, in here you have plus, and that would be 6 divided by 2, which is just 3. And this is your standard form. Now this thing here, we can prove that it's exactly equal to that. And the way that you can do that, or the way that you can actually confirm your answer, is to just expand it, right? If you have some time, and if you aren't sure of your answer, you basically expand it, right? To see if it amounts to the same thing. And if you do this, you actually do get the same thing. So that is how you go about completing the square and having your equation in the standard form. So that is all that I had to talk about in this video. One thing that I can add is that let's say you're asked to find the equation of a circle which passes through, or which has a center, some center. Let's say you're given that C is the center with xy. Then basically the xy values are your a and b, right? So you'd substitute those directly. But what if this circle was constrained, or was said to pass through a point with values x, y, or x1, y1? Then you basically substitute your x1 and y1 into x and y, so that you can find the appropriate value for your r. So not just any circle can pass through this point. So any circle can have this center, but not just any circle can pass through this point. So to make sure that this circle actually passes through the specified point, then you'd substitute that point into the x and the y. Then you'd substitute your center into the a and the b. Then that would give you a value for your r. Now, after finding your r, you just write your formula with the a and the b once again. and you newly found r, so the value of r that you now found after solving. So I guess that is all that I wanted to talk about with regards to the equation of the circle. I'll just expand my discussion of circles in the upcoming video and videos. Actually, I think there are 2 more videos if I'm not mistaken that I'll make about this. So if you do like this video, just give it a thumbs up. If you have any questions, reach out to me. If you want to book a session with me, please let me know. My email is in the description, and if you haven't subscribed, please subscribe, and I will see you in the next video.